And welcome everybody to lesson 7.3. Today's lesson, how do you solve equations that contain radicals or rational exponents? It'll be helpful to have your calculator with you, and of course these notes as we go through. So basically there are 4 steps to follow. First is to isolate the radical to one side of the equation, if necessary. Maybe it already is isolated, so you don't need to worry about that. Then we are going to raise each side of the equation to the same power. So we're going to notice we're going to use the same power to eliminate radicals, okay? Solve the resulting equation, and then it's important to check your solutions, okay? So let's get down to business and solve a few of these here. Solve the radical equation, okay? Cubic root of x minus 2 is equal to 0. It's really not too bad. Our first step is to isolate the radical. So we want to get this cubic root of x by itself. So we're going to add the 2 over. Pretty simple stuff. So 2 is equal to cubic root of x. The next step is to power each side. So since we have a cubic root, we are going to cube each side, okay? That is going to cancel the cubic root out, and little old x is just going to come out. Now 2 to the third, that's 2 times 2 times 2 is 8. So it's not 2 times 3, it's 2 to the third power. Okay, so that was solving, so it's actually already solved for. So step 3 is already good. Step 4 is the check. So you will have some equations in which it does not work, but fortunately the checking is not too bad. If we take the cubic root of 8, so we're putting it back into the original equation, and we subtract 2, we should get 0. Well, cubic root of 8 is 2, minus 2 equals 0, so 0 equals 0. You can do the check all on your calculator if you want, but it works out, so that is our solution. All righty. Next example here, okay? Really same idea. We want to isolate this square root, okay? So everything else we need to move over. So we're going to add the 1 over first to make it 9. Then we have 3 times the root of x plus 4, and we have to divide by the 3 next. So a little bit more work to isolate the radical. Okay, 9 over 3 is 3. Now, to undo a square root, we have to square both sides. So you may forget that if there's not an index given to you, there's an imaginary 2 here, and that is going to cancel the root out. So x plus 4 just comes out. And we have 3 squared, which is 9. And then solving that, we get x is equal to 5. Now, before we formally decide that's an answer, if you take your calculator and you type that in, replacing x with 5, as I'm doing in the calculator, and we do minus 1 at the end, we should get 8, and that does work out. So that is a checked solution. You can use your calculator to determine that. Okay, so those are single radical equations. We have a few more types. We have the double radical, okay? And it's not as scary as what it may seem. So this one's just a little trickier. If you have 2 radicals, you want to split them up, okay? So we're actually going to add the x plus 1 radical to the other side. What that then makes it is 2x is equal to square root of x plus 1. So both radicals are equal to one another. We broke them up. The nice thing about that is we can square both sides to get rid of the square root. And on the left, little old 2x comes out. On the right, x plus 1 comes out, And that's just an easy equation to solve. Just subtract x. So x is equal to 1. Pretty nifty. Again, it's worth checking these answers. So calculator, 2 times 1 minus square root of 1 plus 1. Okay, 0 equals 0. Checks out. It's good to go. Okay, so that's with 2 square roots. One of the more challenging is like number 4 here. This one has a square root and then a non-square root. So the root's already isolated, so that's good to go. We are going to square both sides, and then the fun begins. That would become x squared is equal to just x plus 6. Now we need to remember, how do we solve that? Well, that's from our past information. Remember, we can set that equal to 0. So we would set it equal to 0. Then we had to find factors. Factors of negative 6 that add to 1 would be negative 3 and positive 2. Then you have to split up and solve. So you're going to have 2 possible answers. Okay, and this is where it's very important to check. So check when you have 2 answers. So we are going to try out 3. So we want to know, is 3 equal to square root 3 plus 6? Well, is 3 equal to square root of 9? And yes, it is. So 3 works. I'm going to box it. Negative 2. Is negative 2 equal to square root negative 2 plus 6? Well, negative 2 is equal to the square root of 4. Square root of 4 is a positive 2, so this one is not an answer. We call those extraneous. You can just put extra. That's okay. So the only true answer is x equals 3. You do want to get in the habit of checking those. Otherwise, you might lose points if you put both. Okay, so problems with x squareds, you're going to have 2 solutions you need to check. Okay, the last 2 problems involve fractional exponents. They're really not all that scary. So this time you need to isolate the fractional exponent, because really that's a radical. So we are going to add 2 to both sides. Add 2, add 2. We would have x to the 3 halves is equal to 27. Now, to undo this radical, we're actually going to raise to its reciprocal. So we're going to raise it to the 2/3, sorry. So 2/3 reciprocal power. And that you're going to use your calculator for. 27 to the 2/3 is going to equal 9. So x is equal to 9. Again, you can check that by using your calculator. 9 to the 3 halves minus 2. Well, 9 to the 3 halves is 27. Minus 2 is going to be 25. So reciprocal powers if you have it like that. And the last example, this should be pretty easy. Add 8 to each side. Bada bing, bada boom. X to the 3 halves is equal to 8. We then raise each to the 2/3. To the 2/3. And 8 to the 2/3 gives us 4. And if we check that, it should work out. Okay, so that's solving. Okay, isolate the radical. Really shouldn't be too crazy compared to some of the other things we did. Good stuff, guys, and have a nice